If you've ever taken an engineering class, you've most likely talked about the Boeing 787. The production of this aerospace spectacle has changed the very idea of global manufacturing. Let's see how the manufacture of Boeing's new aircraft compares to that of their staple aircraft, the 737.
Producing 48 airplanes a month on an assembly line. It's a global company, and it takes a lot of people and a lot of manufacturing facilities to build these airplanes. If you think about how many parts that go into a 737, including the wire and all the little pieces, that's a lot of parts that somebody has to assemble. So it takes a long time, and to produce 48 of those a month is pretty significant. And we've been ramping up over the last 10 or 12 years to get to that point.
Boeing's innovation and global participation has allowed it to lead the advances in aerospace manufacturing.
Well, typically we started building airplanes out of spruce wood, and as the jet age came into existence, we started building them out of metal, particularly aluminum and titanium. The 787 is a different concept altogether. It's made out of composites, or a type of plastic with reinforcing in it. Nobody's ever built an airplane of this size out of composite.
Traditional aluminum components are either cut or milled to shape. However, with the manufacture of carbon composites, the parts start out as strips of carbon fiber. To give it shape, these strips are laid down on a layup mandrel, essentially a large mold, after which the carbon fiber is baked under pressure in an autoclave oven until it is cured. Because composite manufacturing on this scale is so new, Boeing uses vendors from all over the world to increase capacity, namely Japan, Canada, the UK, France, Sweden, Korea, Italy, Australia, and of course the United States. In order to transport parts from all over the world to be assembled in the United States, Boeing developed the LCF.
Okay, the LCF is an acronym for Large Cargo Freighter. And when Boeing decided to build the 787 Dreamliner, knowing they were going to go all over the world to produce these parts in pieces and bring them back to Washington and put those pieces together, if you will, they had to devise a way to get the parts to the assembly line. And so they took 3 existing 747 or 747 airplanes and converted them basically by cutting the top half of it off just behind the cab, and then they completely changed the tail end of it. So now the tail end of the large cargo freighter swings open, and it's like driving parts into a big garage on wings. And so barrel sections of the fuselage are put in there, wing sections are put in there, and other parts. And so they're able to transport that around, or parts from around the world, and bring them back to Seattle and also South Carolina, where they're also building 787 airplanes.
Bringing parts from all over the world in the LCF comes with a cost, roughly $13,000 in fuel per flying hour. However, instead of making all their parts in-house, Boeing continues to be a global company. It's just like bringing Legos together to assemble them, instead of creating each individual Lego one at a time.
Boeing has always outsourced some of their work. We just don't have enough factory space or room to do it all. So Boeing is a worldwide corporation. We've got suppliers all over the world. We've got factories in a lot of parts of the world. The issue with the 787 was that this was a first for a lot of people, a lot of manufacturers, a lot of suppliers. They're used to the typical machining techniques. We're learning this together with our suppliers.
The 787 is a large forward step in the advancement of aviation. Boeing is able to produce a lighter, stronger, and more efficient airplane. The lessons learned from the 787 will be applied as the aviation industry shifts toward using composite materials on a much larger scale.